We're on.
Excellent. Welcome, everyone. It looks like we're live here. We'll get started in just a couple seconds here. So welcome and thank you for attending this webinar presentation, Preliminary Insight from the Energy Step Code Costing Study. This is the third webinar in a series presented by the Energy Step Code Council. Switch the slide here. Apologize, we're seeing a slight delay. And just very briefly, the Energy Step Code Council, it's worth noting, who's presenting this work and has been collaborating on the Energy Step Code and related regulations. It's an advisory council established by the province that provides advice and shares information related to the Energy Step Code and represents a range of different stakeholders from trades and professional organizations, utilities, all levels of government, and builders and developers in industry, all working collaboratively together to make sure that the Energy Step Code is successful for everyone involved. I'll be your moderator for today's webinar, Zachary May. I'm the chair of the Energy Step Code Council, as well as the acting director of policy and codes development with the Building and Safety Standards branch of the province. There we go. Today's presentation, as you can see, is going to focus on the Energy Step Code, and we won't be getting into too much technical detail, but taking a look at some of the financial and practical implications for policy and organizations working on the Energy Step Code. The Energy Step Code itself is a transitional roadmap from where we are today in terms of energy efficiency in buildings towards our 2032 commitment in the Provincial Climate Leadership Plan, take buildings towards net zero energy ready, which is really the most energy efficient buildings we can build, and to put that into the BC Building Code by 2032. That's a really ambitious goal and a transition that we're going to have to make in incremental steps, which is what the Energy Step Code maps out. The first step that's worth being aware of is this enhanced compliance step, step 1 on the visual there. This is really laying the groundwork for the Energy Step Code. Before we start improving the energy efficiency of buildings, step 1 asks builders to build a building as efficient as the building code using the new tools, approaches, and language that we talk about in the Energy Step Code. That's our way of creating a consistent language and approach for energy efficiency as we move towards that 2032 goal. If we look at the incremental steps beyond this step 1, we can see 10 and 20% better. Steps 1, 2, and 3 here for houses and small buildings represent what are called the lower steps. These are able to steps that we're able to build with conventional materials and approaches today and really help builders build capacity. This is where we're going to see local governments primarily, not exclusively, but primarily focusing. And you'll see that in the presentation from the City of Richmond today. Generally speaking, in this transition to 2032, the costing study is helping us understand the opportunities and challenges as we make this transition, not just through the lower steps in building capacity, but making that final leap towards that 2032 goal of net zero energy ready by that point in the base BC Building Code. And the costing study, which we're going to see some insights from today, really helps inform us where we can make progress today and where we need to do more work and demonstrate some leadership to overcome barriers that are being identified. Moving beyond these lower steps, we get to the upper steps. These are really our long-term targets. Once we've built capacity in the industry through the lower steps, we need to work with innovators today, some of whom are building these net zero energy ready projects, as well as real opportunities for public sector leadership to overcome some of the cost and practical barriers to build these buildings required to achieve our climate leadership targets identified in the Climate Leadership Plan. And we'll hear from BC Housing regarding some of the initiatives underway to start identifying how we can lead the way and really build capacity in the industry for these long-term targets, not just the incremental changes in the lower steps. But the focus of today's presentation will be on implications from the costing study that has been supported by a number of partners that were members of the Energy Step Code Council: BC Housing, the province, BC Hydro, City of Vancouver, as well as in-kind contributions from Natural Resources Canada, all interested in making sure that we have a really good, clear understanding of the Energy Step Code and all of the financial and practical implications of implementing the Step Code throughout the province for a range of different housing types. We're going to hear from 3 different speakers today, first of which is Dave Ramsley, Principal at Integral Group. Dave has been leading the work on the costing study with a number of different partners involved there, and he's going to provide a bit of a peek at some of the preliminary findings from the study. After Dave, we're going to hear from Bill McKinnon, who is an energy manager at BC Housing, and Bill has spearheaded a really ambitious initiative at BC Housing to provide public sector leadership by encouraging the higher steps for affordable housing projects. So a really interesting balance there between balancing the need for affordability as well as improved energy efficiency. And last, we're going to hear from Brendan McEwen, Sustainability Manager at the City of Richmond. You can't see him on the screen today. We have some webcam issues at the City of Richmond today, but he will be speaking to us, and he's going to walk through how one local government is working to implement the Energy Step Code with balanced bylaws, policies, and incentives to help support that transition towards those long-term energy efficiency goals. Before I pass it over to Dave, I will ask those of you on the line to mute your phones and would invite you to ask questions throughout the presentations in the chat box on the side. I'll be monitoring that and then asking the panelists those questions at the end of their presentations in about 40 minutes time. With that, I'll pass it over to you, Dave.
Great, thanks, Zach. Just want to say hello to everybody who's on the call today, and also thank BC Hydro and the province for inviting me here, and also BC Housing for sponsoring this study. The Step Code is near and dear to my heart in terms of writing the initial white paper and leading that process that started a lot of this process off, and then working with the Energy Efficiency Working Group and then the Step Code Council to get the Step Code done. And then we also worked with the City of Vancouver on their policy work, which was, I think, really informative in terms of a lot of the technical requirements of the Step Code. So what I'm going to do today is I'm going to walk you through what we've been calling the Step Code metrics study that we've been working on since late last year, and what it proposes to understand on behalf of the Step Code, some of the outcomes, and then we'll end off with some insights and recommendations about what this means in terms of the impacts of the Energy Step Code. Just going to wait for my slide to advance here. Usually the first ones are a couple of, there we go. So when we talk about the metric study or the costing study for the BC Energy Step Code, the focus is on what are the impacts to construction costs. So, and when we include construction costs, we include both labor and materials. We do not include design fees, and we do not include land costs or permit fees. And the reason for that is because those things are highly variable. You can see on the pie chart to my, just on the side of the screen there, that if we were to look at the Lower Mainland, for example, the majority, or at least half of the costs for a new home are wrapped up in the land. And that number is significantly lower when we move to the north of the province. Again, permit fees and design fees can be very variable, but what we do know is that there may be some impact on how you put the building together, and that may be reflected in the construction costs. So that's what we're trying to understand in the study. I'll talk about some other outcomes just in a moment. In terms of how we understand costs, we believe this to be the largest energy modeling exercise for a code that's been done to date in Canada. And I'll talk a bit about that and the reasons for that. But before we get to that, people always want to understand, how do we get to these costs, and where do the costs come from? These costs were extensively vetted by industry. So, many of the Part 3 costs you're going to see today come from actual project experience, lived experience by both Integral Group and Morrison Hershfield on real projects that we've worked on. They've also been vetted through public process with industry and with contractors. And then on the Part 9 side, those numbers came from a large federal study called the LEAP program, Again, those were vetted in multiple jurisdictions across British Columbia and vetted with builders and ground truth against what they were seeing. And then we had also E3 Eco Group, who does a lot of consulting locally on high-performance buildings to, again, go through those numbers one last time to make sure that they were accurate and up to date. In terms of the team that we are leading on this, I talked a little bit myself. Integral Group, we are the head of the project manager. We're using Morrison Hershfield for the Part 3 energy modeling in the building envelope requirements, E3 Eco Group for Part 9, and then we have some support from Natural Resources Canada in terms of in-kind contributions, in terms of technical support, and then they've also supplied us with a local contractor, Remy Sharon, who has undertaken a lot of the optimization and energy modeling. He's also been a great resource in terms of providing some specific technical feedback on the Part 9 solutions. And then you can see our partners who are reviewing our work regularly at BC Housing, BC Hydro, and the province of British Columbia, who have been providing technical oversight from this on the client side. So, background's changed on this a little bit. I just wanted to talk about why is this such a large energy modeling exercise? Well, in British Columbia, we are fortunate to have all of the climate zones you would find all across Canada, all in our one great province. So that goes from the Lower Mainland here in Climate Zone 4, the Okanagan in Climate Zone 5, what we were referring to as the Southern Interior in Climate Zone 6, Northern Interior here, Peace River region, and then far north. What we're going to focus on today, as you can see from the bar chart beside me, and I think there's a bit of a formatting issue because I admit I'm a bit of a Mac guy and it doesn't always come through on the PC files, is that we're going to focus on the southern part of British Columbia. You can see that we are, like the rest of Canada, most of us live within 200 kilometers of the US border, and 90% of our province lives within these 3 climate zones. So we'll be going a little bit deeper on a couple of tiers, and we're going to primarily do it for the Lower Mainland region. So that's a lot of variables that we have to work with right off the bat. Just we have to model it for every climate zone. The second key piece, which is different from maybe other energy modeling exercises, is that typically when we do this type of research for government, when we look at the costing impact of a code, we'll typically take the prescriptive requirements of that code, and then we'll look at what the old code was and what the new code is proposed to be. And we match up those prescriptive requirements, we apply cost to them, and we see what the difference is. The difference with the energy step code is it's a purely performance-based standard, so there are no prescriptive requirements with it, which can present a challenge for those of us who do costing. So what we had to do in this case, we had to model every possible permutation of what the energy step code could yield, and then using, I guess, a filter analysis of what is most likely to be built, what is the lowest cost to be built, we filter through all of those possible options to get to our lowest cost option and yield the costing outcomes. So what this led us to do is we used some parametric modeling software. We looked at a variety of different archetypes. We looked at all of these different possible energy modeling combinations. And just on the Part 9 side, we did over 129 million different simulations in terms of looking at how all of these different combinations could fit with different steps of the BC Energy Step Code. So it's a bit different than the way we used to do things, where we kind of rely on, this is the professional opinion of how we think we would comply with it, these are the changes we would make, or this is the prescriptive requirements, to looking at, okay, these are the optimized results, and then we provide a professional lens to it to say, yeah, that's buildable, that's practical, this is likely what people would do. So I feel it's going to give us much more robust results and much more comprehensive results. We've literally left no stone unturned in terms of the approach forward. In terms of the background, so this is just a snapshot of the broader study that will be coming out later this summer. It'll look at 15 different archetypes across both Part 9 and Part 3 construction, as I said, in all climate zones. So lots of different outputs there. The focus of the report is on costing, but it's really to measure from a policy perspective, what are the affordability impacts of potentially adopting the BC Energy Step Code in your jurisdiction at a given level, and what's the practicality of it? So, how are these steps going to be built? Are there solutions that are viable in your jurisdiction to be able to go to steps 1, 2, 3, or 4 or 5? And I really feel that it's the empirical data to help inform implementation. This is one of the great hopes of the BC Energy Step Code. Of course, we work for Vancouver, we work for Richmond, we work for Surrey. They can afford to hire some consulting expertise in terms of helping them deliver green building policy, but there are lots of other jurisdictions across British Columbia that can't afford this, high-priced consulting help to be able to do this type of empirical and vetting and costing analysis. So by doing this all once comprehensively, our hope is to be able to give this to local governments across the province so that when you want to adopt the BC Energy Step Code, you have the absolute best data to be able to give to your councilors and decision makers, or to maybe involve in your public process, whatever you're going to do to move forward on it. So today we're going to discuss 4 archetypes: medium single-family home, rowhouse, a mid-rise multi-unit residential building, that's what MERB stands for if you're not familiar with that acronym, and a high-rise multi-unit residential building as well too. And we're going to focus on these today because 15 archetypes is just too many to get through in the 20 minutes that I had. So before we get into the costing analysis, I just want to make sure that while we're presenting these costing results, they are put in context. We always do these analysis prior now to adopting energy requirements within the building code, and the reason why we do it is because we're worried about the potential for impacts on affordability. We're fortunate, I guess you're getting old when you've done two code cycles of costing analysis on energy impacts, and I'm fortunate or unfortunate enough to have done these now. And what was interesting was I was thinking, okay, well, we're doing this forward look at what the cost impacts are of the BC Energy Step Code. Why don't we look back and see how accurate we were in the past at forecasting the impacts of other energy efficiency requirements and what those impacts were on affordability. So this graph we prepared here, just put it together over the last week. And what the blue and green lines are is that they are the book value, or in terms of the cost reference guide that industry commonly uses to price jobs. So Altus is a consulting firm. They publish the book rates on the cost of construction every year. And what we did is we actually went back all the way to 2007 and did right up to 2017, did the 10-year look at what the forecasted rates of construction were expected to be year on year. And then this orange line is actually based on StatsCan data about a look back and seeing what actually were the per square foot costs of construction. We only have that one for residential, we don't have it for commercial. So in 2008, prior to the energy requirements of the BC Building Code, we expected a 2% increase in cost of construction. In 2012, we expected about a 2.2 increase in cost of construction. What we found is that actually they had no impact on the cost of construction over time. So in fact, there was a precipitous fall. This is aligned with the recession. There was, forecast to be no impact when we looked at the Altus numbers. And when we looked at the StatsCan numbers, what we found is actually in the 3 years surrounding the implementation of the code, so the 1 year leading up to it, the 2 years after it, those were actually the times where the cost of construction increased the least. So it was the lowest year-on-year increase in construction costs outside of the recession. So take all of these notes with a grain of salt. The cost of construction is a highly complex animal. Maybe there's an impact on construction, but the data doesn't seem to show it yet. And I just want to add that caution before everyone starts taking these numbers as gospel. So now the results. One last framing slide in terms of how we've color-coded the results. We've heard from industry that they would like to see, they think that 1% cost premium is probably, their level of comfort, where they want to go. Where we've seen in the past in terms of other energy code updates province-wide, 1 to 2% has typically been sort of the benchmark that we've used. And we've seen that that's had, at this point, no measurable impact over 2 code cycles. 2 to 5%, this is where we're starting to say, okay, there probably is some correlation to cost, and we may want to see some short-term incentives. Spoiler alert for this study, no climate zone experienced at step 3 a higher impact than 2.7%. So we're pretty close to that 2% number. We are closer to that than 5 moving forward. So our first archetype is medium single-family dwelling. Just to orient you how these slides work, here's a picture of what that archetype looks like. Here are the steps listed on the vertical axis here, and here are different climate zones as we move across, escalating up. Remember, the blue is everything that's color-coded between 0 and 1%, and then green is 1 to 2%, and gray is everything over 2%. I noticed one typo just as I was doing this morning, and that this is the only cell, I assure you, in the whole one that should be colored blue, not green. So the results are even better than I'm showing here. But what we're seeing is that when we look at the lower steps of the BC Energy Step Code, specifically for a medium single-family home, roughly 2,600 square feet, that we're seeing really excellent results right across the province. Really the only in the very far north where less than 2% of our population live, we're seeing everything is under 2%, and in many cases we're seeing majority of the results under 1%. What I also want to point out too is that there are some results here that you're going to see that there's actually identified cost savings, and that's as Zach mentioned off the top. There are points where the BC Energy Step Code uses a new framework, a new methodology by which we look at energy utilization in buildings. And we're finding that by using those new methods, we're able to still achieve a greater level of energy efficiency, but perhaps at reduced cost. And I think that's what we're all looking for when we're writing energy policy these days. It's not just more regulation, but better regulation, right? How do we actually find that economy of requirements that allows the creativity of industry to deliver the most energy efficient building possible at the lowest price to the consumer? So, we're greatly encouraged by some of these results. And we feel that it would actually be a benefit to industry in some cases to adopt the Step Code as your base code to get us cost savings. We have provided across the bottom here people always want to say, okay, well, what does that building look like that complies to the BC Energy Step Code? So this is basically, I've tried to provide a bit of a snapshot of all of the different components that may go into that building, and then highlighted the areas where there is maybe a deviation or a change that's brought about as a result of the requirements. So we're looking at step 3, this cell right here, 1.4% potential cost increment. We're looking at it for the lower mainland, this orange part within the province here. And what you can see is we see pretty much standard kind of code responses across the board here in terms of how that building is complying. The only difference is that we're seeing a bit more attention paid to air tightness, 2.5, not out of the realm of achievability by any means, but a little bit better than what we typically see out of common construction methods or tested common construction methods here in the lower mainland. Slightly better windows, and we are seeing a bit of an exotic domestic hot water system. So they are using a heat pump for the hot water tank. But again, we did do a practicality check on all of these things. These are all pieces of equipment that are available at your local Home Depot, Lowe's, etc. So the heat pump, while not broadly used right now, is very widely marketed and available throughout the province. So that's basically what gets us to that 20% plus improvement in both energy efficiency and greenhouse gases. We have GHGs saved over here. You're only seeing about 1.5 tons saved per home. The average home in the lower mainland generates about 6.5 tons per annum in terms of the how much greenhouse gases it produces. Just waiting for my slide to advance here. It doesn't double up. There we go. Market Rowhouse, really great results right across the board here. So we're seeing majority blue right through the province. Everything's still below 2% though, no matter where we look. Really great applicability, we think, in the Okanagan Southern Interior for this, because we're seeing that actually step 3 is probably cheaper to implement than the current base code. Keep in mind that the code itself does escalate in stringency as we get further north in the province. So we all compared these costs against the baseline costs of the code. So again, what does that building look like in the lower mainland? We're looking at step 3, again in this orange part here. We can see a bit of an improvement in air tightness, and again, just by changing out the hot water tank. But pretty much, we're seeing pretty standard code values across the board here. Maybe a little bit higher on your floor value insulation, but that's not something that is going to be cost prohibitive or difficult to deliver at all. So again, a great example. This the Market Rowhouse is also one of those forms of development that is a very desirable and low-cost form of home ownership, right? This is something that allows people ground-oriented multi-unit residential buildings, something we're trying to see a lot of in densifying our communities. And then we've got mid-rise wood construction. Again, really strong results throughout, the exception being the Okanagan here, where we're a little over 2%, but really good results even in the north here. The primary differences in that construction are we're going to see higher wall R values, very high roof R values in this one, and then a switch back over to electrically driven buildings. So we'll talk a little bit more about this results just in a second. And then finally, closing it out with a high-rise MURB construction. This is where we saw, the only time where we saw kind of 2 instances of going over 2%, and that was in the Okanagan and the northern interior. But other than that, we're seeing really great results throughout the Lower Mainland, or actually throughout the province. Again, window to wall, or sorry, wall R values are a little bit higher. We've gone back to all electric, and we have seen a higher level of heat recovery than you might actually normally see. The really good news story for this archetype, though, is that your average building in a MURB generates about 250 tons of greenhouse gases per year. We're almost cutting that in half with this scenario that is being delivered at less than 1% cost. So as I close up here, I think that there is, the architecture matters in terms of what we're looking at. If you have a very highly articulated building, with a complexity, it makes it 20% harder for that building to achieve the step code levels than a simplified building does. And then when we look at small buildings, they're quite a bit more challenged to hit these targets than other buildings. But typically, we build those buildings out of wood, which gives them much higher R values at a much lower cost. So we're actually, seeing that trade-off play out here. And then we're seeing this mid-rise development, which played out in those costs, to say it's been very economical to build those because it has this, this positive form factor that we're seeing here, but it's also built out of wood. So it's kind of like the porridge that Goldilocks chose in terms of those two things coming together at once. The only thing I might also note here, and we'll talk a little bit about it maybe in Bill and Brendan's presentations, is that this form of development in architecture is decided very early on, and being able to understand this and get on top of this, may have an impact on, how we permit these buildings. So we don't want a building like this going to urban design panel and then expecting it to perform like a building like this would. So that's something we're going to talk about probably a little bit later today. So finally, my recommendations, all actions past the feasibility test. Architectural details and form required, no exotic technologies were required, and our most affordable units in terms of low-rise MURBs and ground-oriented row houses had our best results, which were very encouraging. In terms of recommendations for implementation, consistent with the step code policy guide, we definitely think that that adopting step 3 at the base code for British Columbia is a very responsible move. I think that the costs are lower than what the last code increase were for the province, and we're seeing great results in terms of savings and cost effectiveness. And then, in terms of using incentives, we really feel that those should probably be saved maybe for the more northern climates and for the upper levels of the step code. And then we really have to look at small projects, and they may be disproportionately impacted. So if you have a laneway housing policy in your local jurisdiction or a small house policy, you may want to look at refining that with different levels of performance of the BC Energy Step Code. That said, this is a little photo I want to end here with from Tim Rice, who is the Deputy Director of Inspections at the City of North Vancouver, who is actually building a small laneway home on his property for his mother-in-law, and he's building it to passive house standards. So way to go, Tim, and showing that it is actually possible. That's it for me.
Thanks, Dave. We've got one quick question maybe you can clarify before we transition over to Brendan, who's next up. Are the costs looking back to 2007, this is one of your earlier slides, in actual or real dollars?
So those stats those are in today's dollars. Those are actual dollars, yeah.
Thanks. Excellent. Thanks very much for that, Dave. It is worth noting before we transition over to the next presentation that certainly the costing study is taking a look at construction's costs specifically, but certainly representatives on the Energy Step Code Council have identified that construction costs aren't in isolation, and energy efficiency isn't the only policy pressure on developers when they're building new projects, and that construction timelines and other policy initiatives always come into bear as local governments make those decisions, ultimately leading to what the actual cost is on the ground for a particular project in a particular situation. But I think if I can summarize what the costing study is showing us so far is that certainly the step code can be part of an affordable package to improve energy efficiency when factored into all those other policies as well. So thanks for that, Dave. With that, we'll pass over to Brendan McEwen from the City of Richmond. All yours, Brendan.
Great. Thank you, Zach, and thanks so much to everyone on the webinar. I'm Brendan McEwen, Sustainability Manager at the City of Richmond, and had the privilege of representing the Union of BC Municipalities on the Energy Step Code Council. So I wanted to begin by noting that there's plenty of compelling reasons to adopt the Energy Step Code. It's certainly necessary for local governments to hit our climate goals. It will support better quality construction, more comfortable homes, quieter homes. It can support improved indoor air quality and reduce households' energy spending. So all of those are really good things. At the same time, affordability of housing is a central concern for local governments throughout BC, and certainly here in Richmond it's a priority. We're developing an update to our affordable housing strategy. So, you know, I'd say in light of the very real affordability challenges, the costing work that Dave just presented is hardening because the premiums for step code are quite modest, particularly for those lower steps. And I think one other thing that's just important to acknowledge is that an increase in the cost of construction, if there is one, won't necessarily be borne by home buyers or renters, particularly in cases where you have a developer developing land, building new housing, then selling that. They'll typically sell those units for as much as the market will bear, irrespective of construction costs. So it's difficult to make a link necessarily between construction costs and the affordability of housing. But it's still, of course, prudent for local governments to seek to minimize the cost of construction. So I'll share some of the strategies to do that as part of our step code implementation here in Richmond. The first key point is to begin with lower steps of the Energy Step Code if your local government is implementing requirements that will apply to all new types of some building form, new construction in your community. So again, this makes sense because the cost premium has been shown to be quite modest for these lower steps, and it'll also keep your local government from running afoul of provincial policy. The second point would be to telegraph how your local government is going to step up its requirements into the future. And this kind of telegraphing or foreshadowing your local government step code regime is going to help builders control their costs by helping them to understand what sorts of education and skills they'll need and how to invest in training for their crews or different sorts of innovative building practices that they're going to need to be able to achieve code a number of years into the future. And it can also inform their decision making, for instance, how much to pay for land. So in Richmond, what we've done is have a preliminary council endorsed schedule of step code regime now and into the future for different building types. So you can see here the preliminary schedule for single family and duplex typologies would be to begin at step 1 beginning next year, and then telegraph to industry, hey, we'll be ramping up these requirements over time, get ready. It is appropriate to have greater ambition when value is being added to the property. So here in Richmond, like many other communities, we have a lot of redevelopment where we're going from lower intensity land uses like this old rancher that you see on the left to more intensive developments. And when we rezone that land for that greater density, it adds a lot of value. So currently our townhouse rezoning policy requires better than code performance in terms of Energy Star, and what we'll be doing for this type of housing is adopting a similar level of ambition beginning next year, and again, telegraphing to industry what would be coming into the future. It's also appropriate to have greater ambition for larger, more luxurious homes. So we're exploring having a more ambitious target for homes above maybe 4,000 or 5,000 square feet. And there's, I think, a fairly good rationale for this. Certainly there's less intense affordability concerns for a household that can afford a new 5,000 square foot home in Metro Vancouver. Also, these larger homes use more energy in total, so better standards for them will have a greater impact on our climate and energy goals. And the last thing is that for larger buildings, all else being equal, it is a little bit easier for them to hit the energy step code, which Dave alluded to. We've heard from builders in much of our consultation that a real concern they have around costs is not that the costs will forever be so high, but that there are real costs associated with learning that occurs on the first couple of projects, where they need to learn how to build more airtight or to use construction techniques that might be new to them. So for this reason, it makes sense to support builders through education and training where you can. And here at Richmond, we're looking at a variety of ways we can reduce those types of learning costs for builders, including launching 2 programs this summer that'll help builders better understand how to construct airtight homes before step code even becomes a requirement next year. And hopefully in this way we can reduce those hassles and transaction costs in being able to meet the step code. And the last thing I'd say is that it's important that more projects achieve the very highest steps of the step code right away, so that there can be learning and innovation within the industry. And so based on this small but growing number of projects that begin immediately tomorrow, industry will be able to have a better understanding of what kinds of construction practices are necessary to build to this level, and that'll support innovation and drive costs down. We've certainly heard from builders and developers as part of our consultations here at the city that there's a lot of interest in having some sort of density bonus to be able to achieve the highest step. Preliminarily, it looks like it would take relatively little added density for there to be sufficient value to make up the premium to go to those higher steps. So something we in the sustainability group at Richmond are exploring is what could an incentive system look like to allow for those higher steps to be built. And I really think this should be something that all local governments who are thinking about implementing the step code consider. So in summary, just to reiterate, I'd say begin with lower steps for community-wide requirements, telegraph where you're going to be going in the future with those requirements. It's okay to have greater ambition when significant value is being added to the property, or if it's a larger or higher value home. There's a great case to be made for supporting builders with education and training so that they better understand how to build an Energy Step Code home, and consider incentives for leaders to go all the way right to the highest steps so that others can learn from them and that innovation can help drive costs down. All right, thank you.
Excellent. Thanks very much for that, Brendan. Certainly a great example of how you're using the step code to fit the conditions that work in Richmond and for your own planning needs in that community. With that, I'll pass it over to Bill McKinnon to provide some insight to how BC Housing is working with the Energy Step Code to provide some real provincial leadership. Bill, over to you.
Thanks, Zach. As Zach mentioned, I'm the manager of the energy management team here at BC Housing. And we are, if you're not familiar with BC Housing, we're the provincial crown agency that's responsible for social housing and also partnering to develop affordable housing across the province. And we're in the process of designing about $1.5 billion worth of housing that's going to be, that's in design right now, that will be built over the next 3 years. So lots of housing coming down the line for us. So why the Provincial Energy Step Code for BC Housing? I just wanted to list a few things I'm going to talk about today. One of the things is our BC Housing Design Guidelines and Construction Standards, the benefits to BC Housing to going the step code route, benefits to industry, that the lessons they can learn from us being the first to undertake some of these projects, and then I'll talk about some of the projects that we're working on and some early lessons learned. So BC Housing has been the leader, or one of the leaders, in sustainable building for about a decade. We have reached 31% reduction in our GHG targets as of 2016, so we're a real leader in that area. We have about 60 projects registered with the Canada Green Building Council and over 40 projects designed and receiving LEED Gold certification. This project on the right is Caris Place, one of the great examples of a really good or really well-designed LEED project. But we have noticed as we've been becoming more and more efficient using this the methodology of complex mechanical systems to achieve energy savings, that buildings are becoming much more difficult to operate and have more and more complex systems. So one of the things that we learned about at the time we were having these problems with our systems is the Passivhaus methodology. I was invited by the City of Vancouver to the International Passivhaus Conference. Around the same time we were having our mechanical issues with some of our more efficient buildings, and learned about buildings that could achieve 80% heating savings reductions by using a building envelope first strategy. We are in the process of piloting a few of these projects, but we're also really looking for a way that we can maximize building the largest number of units, or the greatest number of units. Are
others able to hear Bill?
Everyone good?
Yeah,
Please
I can hear.
comment if you have any issues. Okay. Yeah, so we were introduced to the Passivhaus concept. Around that same time, the Building Safety and Standards Branch approached us to help develop the Provincial Energy Step Code, which was really attractive to us because it allows us to still be efficient while maintaining our affordability. So our BC Housing standards, we have decided to align our standards with the BC Provincial Energy Step Code. We will be requiring Step Code 4 for most of our projects across the province. All Part 9 projects, or smaller wood frame projects, will require that level. And will require Step 3 as an exception for high-rise concrete construction. We're also making exceptions for the region, such as the north on the Part 3 side, and the interior. We're probably going to look at Step 3 for the interior and Step 2 for the north. We have also gone through our design guidelines and construction standards. We hired a third-party sustainability consultant to look at what we do well with sustainability, what great things we're doing with our LEED projects, and make sure that we capture things like water savings and landscaping and all of the great things that we picked up from LEED. So that's also been incorporated into this new release of our design guidelines and construction standards. So the benefits to BC Housing to doing this, really, I mentioned before, simple mechanical systems and lower utility costs. A lot of our buildings are operated by nonprofits, and obviously the lower utility costs are a bonus, but being able to hire staff that don't need to have a significant engineering experience has been great for us. For BC Housing being a provincial crown agency, alignment with the climate leadership plan has been great. The climate leadership plan mentions support for the STEP code and also Passivhaus, so we're able to continue to contribute to that. We also align very well with the City of Vancouver Green Rezoning Bylaw, which is roughly equivalent to Step 3 and Step 4, depending on the type of construction you're working on. We also hope to align with future municipal rezoning requirements as of mid-December, when municipalities start adopting the STEP code. We won't have to teach our design teams to start things from scratch. They'll already be familiar with different levels of the STEP code. We're hoping to align with future incentives. I know there's been some talk from the utilities and from the province to hopefully provide incentives for the higher levels of the STEP code. And step code also aligns very well with our BC Housing corporate pillars. We're expected to be a leader in sustainability and residential construction, so that's been a great bonus for us. Benefits to industry. With us focusing on the higher levels of the step code, it allows us to try out new technologies and to document and share a lot of these new technologies with industry. We're able to provide practical examples to align with some of the work that that Dave and his team has been doing with the Step Code Council on the costing study, and we do very detailed costing on all our projects, and hopefully we'll be able to provide some feedback to that study. Also, one of the big selling features for the step code for us, which I think will be a benefit for industry as well, is consistency between our BC Housing requirements and municipal and provincial requirements. So we don't have one municipality requiring LEED and us requiring the step code. There'll be a consistency across the province with that. And frankly, industry has asked the Step Code Council that they want government to lead. So we are really leaders in this area, and we plan to continue to be leaders in the provincial energy step code. So we have a number of step code compliant projects in design right now. We have the first 5 projects listed. We have passive house projects in Smithers, Merritt, Fort St. John, Nanaimo, and we're partnering with a nonprofit to build a passive house project in Victoria. All of these projects will meet or exceed the highest levels of the step code. We're also developing, in the process of designing, multiple step code projects across the province at the step code 2, 3, and 4 level. So we'll have lots of results to share with everyone. Some of the lessons learned, early lessons learned from these projects, I think Dave touched on articulation, getting involved with the design teams very early and letting them know that you're going to be targeting the higher levels of the step code, or what level you're going to be targeting, so that they can work on things like aspect of the building and the articulation of the building and window to wall ratio, things like that. Really challenges to design teams have been some of the urban design panels or city councils don't understand some of the things that are necessary to meet step code, AAV valves, heat pump, hot water tanks. So there's definitely a lot of room for education in the design community and with municipal officials to let them know that if we really want to promote this, we have to allow for those new technologies in designs. And I think one of the big things we've learned is once design teams have been through a step code project, once they've been through the design process, the next time they're on a project, it just becomes 10 times easier. It's much less risk, much less cost, and much less time for a project to get off the ground. So I wanted to be really brief so we have time for questions. Feel free to contact me if you have any questions about BC Housing's policy. We'll be releasing a technical bulletin hopefully by the end of the month on our new standards, along with a copy of the new energy and sustainability standards section. And we'll also be releasing a guide sheet to meet the step code for our projects. And like I said, get a hold of me, visit our website for more details by the end of the month. Thank you.
Excellent. Thanks very much, Bill. Some really impressive work there to really show some leadership and get some projects on the ground that we'll be able to see and really learn from as an industry. Before we get going with questions, we've got some coming in. I would invite you to use the Ask a Question section in your control panel, and we'll go through the questions. If other questions come up afterwards, it's worth noting you're welcome to email the Building and Safety Standards branch as well at building.safety@gov.bc.ca. The first question we have is directly to you, Dave. Morgan McDonald from Ledcor asks, how do you quantify the premium for achieving better airtight, more skills, training, labors? How is that factored into the costing study?
So we primarily factored in better airtightness just by adding some more labor to the building envelope finishing. So typically, a bit more taping, it was basically by adding, I think in some cases, 18 to 20% more on some of the finishing details and finishing work for the airtightness. So, there's not any exotic materials being required. It's just a better level of fit and finish. So this is in consultation with builders who told us that that was the best way to factor that into the overall rise in construction costs.
Maybe a follow-up to that, how is the work of energy advisors or energy modeling factored in? Is that additional labor, or is that included in the study?
It is included in the study. So, you know, when all of those, if you recall, when I presented those numbers across the top in step one. So step one, it said up to 10% more, or sorry, up to, yeah, I believe it was up to 1% more of construction costs. We factored in the CEA costs into the construction budget. That's the only kind of sort of what is traditionally a soft cost that we incorporated in, just because we recognized it was directly related to the implementation of the step code and a new cost that maybe not all Part 9 buildings might be factoring in. So, so that one is kind of the exception in terms of soft costs that we put in there. But just because we wanted to make sure that it was, you know, that airtightness testing and all of that was we were giving the whole picture in terms of this costing study.
One question maybe to myself, but I'll ask for comment from Brendan and Bill, is why there are no GHG targets in the energy step code if ultimately what we're looking for is a reduction in GHG emissions. I can certainly state from a building code perspective, the building code has a tradition of being fuel neutral and just providing clear technical standards regardless of the fuel that builders choose to use. And so there was a decision made very early on in the process to stay committed to that basic principle of the BC Building Code and the National Building Code. But Bill or Brendan, do either of you want to comment on how your organization or community might be addressing that GHG question separate from this step code?
Well, Brendan here at the City of Richmond, certainly, you know, a key goal that we have is to reduce greenhouse gas emissions from our community. I do think that there may be some value in having a GHGI target, greenhouse gas intensity target in the future, and so that's something we'd like to keep in discussions, but we still think the step code will be extremely valuable to drive reduced emissions, and we're looking forward to implementing that.
And I just add to that the bulk of our GHG emissions are associated with heating energy, and when we go to the higher levels of the step code with the building envelope first design, we're capturing a lot of those GHG emissions reductions mostly by moving over to very great building envelope and very high levels of insulation, and we can move over to simpler heating systems like electric baseboards that have much lower GHG impact.
Perhaps related to that, we've got a question here about whether the step code encourages the transition to electric heating or energy sources. Dave, do you want to comment about what kind of fuel options are available in all the different models you ran in the different steps?
Yeah, so you know, the step code, for those of you who may be new to it, has two primary metrics that transcend, I guess, all of both the Part 3 and Part 9 characteristics. Those are total energy use and then a thermal energy demand intensity metric. The one that really maybe motivates fuel choice in the BC Energy Step Code is the total EUI metric. So the total EUI metric looks at all of the energy outputs within a building, energy consumption that happens within a building. And when we look at that, we see that heat pump solutions, in terms of whether it's for hot water or whether it's for space heating, are lower overall in terms of the energy use intensity for buildings. So, you know, we look at something that is maybe 300% efficient as opposed to being only 92% efficient. And for that reason, I think that when we look at the upper ends of, you know, whether it's both Part 9 and Part 3, switching, there does become a point around, you know, we can use all fuels pretty much throughout the step code, but it does, the solutions that use heat pump technology tend to kind of start picking up steam around step 3. Just because they lower that overall energy use. So I don't know if that's consistent with what Bill's seeing in his projects, but that's kind of what the narrative of the story, how it's unfolding for us in terms of what we're seeing in the model results.
On the passive house projects, we're definitely finding that's driving us to heat pumps for hot water.
Yeah, and that seemed to be something that was surprising to us in terms of a technology we hadn't used a lot or hadn't seen a lot, and now we're seeing a lot more of, just at least in the research.
If electricity costs increase more quickly than natural gas or other fuel sources or renewable energy for that, like on-site renewables for that point, any comment on what costs we may see, how that impacts owners, operators of these buildings? Is the energy efficiency offsetting any potential increases in cost? And was increasing cost of electricity factored into the study?
We did look at cost increases in electricity. We did look at total costs of electricity. In some cases, we're saving 50% in terms of energy use in higher steps, and that more or less it can make up for the added costs in terms of electricity. In some cases, it's not. You may want to look at going to a natural gas solution for a more cost-optimized solution. We did look at longer-term paybacks, and typically a lot of those solutions, just with the inherent cheapness of natural gas for the consumer, we did see that some of those solutions maybe were better off or more advantaged over the longer period than the electrical solutions. But we're much higher in GHGs, and I guess there's just other trade-offs to look at there.
Brendan, there's a question around the specific targets that you'd identified for particularly large homes being potentially required to go to step 3. Do you want to comment on how that's been received during consultation and where you're at in that process and what kind of feedback you have received?
Sure. It's still quite early days in our consultation, and it is a preliminary target, but to date we haven't received any comment that is I would say is negative or saying we're not able to do this. But then, I would emphasize again, we've had just a couple of meetings with builders to date, and they're mainly still learning about this, absorbing what the step code is, what it requires. So we'll see how it unfolds.
Thanks, Brendan. Dave, in terms of the costing, I've got one question here around what the assumption was for construction costs per square foot for residential construction.
I'd have to go back and check. I mean, we used a wide variety of numbers, but basically we used, the LEAP process gave us a base cost of construction. We used the Altus construction guide in terms of looking at those costs of construction. So there was different costs for the residential than there was from the commercial to the multi-unit residential. So all I can say is that they were the latest published industry rates that were then vetted by builders as well too.
Okay. The question asked specifically whether it was $500 a square foot, but is it fair to say it was it's lower than that? That
sounds about right, or close. It's close anyway. It's in my slide if you wanted to kind of look back and chart exactly where we are in 2017 based on the StatsCan and the Altus guide. So these slides are available online afterwards. It should be right there.
Okay. And that's for single family as well as large commercial?
That $500 number is more residential. It's for single family. Single family row house, pretty much any ground oriented residential.
Okay, thanks. When will the study be released? When can we see it? Will it be public?
Yeah, so I think we're in the final countdown here. Our hope is to have it finalized within, by mid-August at the latest. So the idea would be that when everyone from local government here is back at their councils are back meeting in September, they'll have this great asset to be able to use in terms of developing their own step code policies.
Excellent. Bill, to you, have any BC housing projects to date approached or entertained the idea of actually getting to net zero or possibly even net positive?
We definitely have had some quotes on some of our passive-house projects for renewable energy systems, but we haven't. We don't officially target net zero currently, and none of our projects meet net zero as they stand. None of the existing LEAP projects.
Excellent. Thanks, Bill. I should note we have more questions here than I'll have time to get to. We'll get to one more here. In Smithers, we see a gap between the work of BC Housing on their current passive house projects and what private developers can accomplish. Can you talk more, Bill, about closing the gap between government-funded projects and market-based projects? I assume in terms of that level of ambition that you're able to push for and what the market is able to do on a strictly cost basis.
Yeah, and I think that's the passive house projects like the Smithers project and the others I listed earlier in the show are considered pilot projects. So we're really trying to determine what's possible. I know that the costs are higher for passive house projects, especially in the northern regions. The costs are coming in higher. I think we're really coming close to the mid-upper step code level costs when we're looking at the interior, lower mainland, and the islands. So I don't think it's as big of a challenge. But really, those projects in the north were intended as pilot projects. We, as I mentioned earlier in the slides, we're targeting step code level 2 currently until the Building Safety and Standards branch comes out with specific targets for the interior and the north. We're using the lower mainland targets for step code level 3 for the interior and 2 for the north. So there's definitely a gap, and I think what happens as you get it into the extreme north is you start getting back into those more complex mechanical systems. One of the projects we're looking at is we're building in Fort St. John, and we were very, very early in design on that project, and we're discovering, you know, some of the systems we'll almost certainly need to use heat pumps. We might have to use sewage heat recovery. We're probably going to have to obviously we'll have to hyper insulate the building. So there's a lot of costs that a typical builder wouldn't, or a typical owner wouldn't be able to carry. But that's the price of being a leader, I guess.
Excellent. Thanks, Bill. Well, on behalf of the Energy Step Code Council, thanks certainly to our panelists for great presentations and discussion, and thanks to everyone for tuning in, sending us your questions. We will be sending out an email note with links to downloads of different resources of the presentations, as well as a recording of today's webinar. So thank you everyone for participating, and look forward to continuing the discussion in the months and years ahead. Thanks everyone.
Thank you.